This video is on the factor theorem. So the factor theorem is used. We use synthetic division to determine if a binomial is a given factor of the polynomial. So a few things we need to know. The important part of this lesson is knowing what the remainder means. So if our remainder equals 0, then it is a factor. If our remainder does not equal 0, so any other number, it is not a factor. So let's look at our first example. It says determine whether the given binomial is a factor of the polynomial. So this is our binomial right here. And then our polynomial is going to be this right here. So what we need to do is first we're going to take the binomial and we're going to set it equal to 0 and solve for x. So to solve for x, I subtract 1 from both sides and I get x equals negative 1. And then from here, it's just synthetic division. So synthetic division, we use negative 1 in the little half box. And then I'm going to take the coefficients from the polynomial. So I have 1, negative 3, and a positive 1. And I leave a little bit of space, and I draw a line. Remember, if it's above, we add. If it's below, we multiply. So the first term gets dropped down, and then I multiply. Negative 1 times 1 is a negative 1. Negative 3 plus negative 1 is a negative 4. And then I multiply because it's below. Negative 1 times negative 4 is a positive 4. 1 plus 4 is 5. This last part right here is the remainder. And as we notice, it is not 0. It is not equal to 0. It's a different number, so this is not a factor. And that's it. Okay, so if we were to factor this polynomial, x plus 1 would not be a factor. Looking at example B, same directions, just new question. So we're going to take our binomial and set it equal to 0. I add 2 to both sides, and x equals a positive 2. So this is what goes in my half box for synthetic division. One thing I forgot to say in the last example is we need to make sure that our polynomial is in standard form and it's not missing any exponents. So looking here, I have x to the 4th, x cubed, x squared, x, no x. So it's in standard form and I'm not missing anything. What I mean by missing anything is it does not jump from x to the 4th to x squared. It has 4, 3, 2, 1, 0. So again, we're going to take our coefficients. So we have 1, negative 8, positive 10, positive 2, and 4. I leave a little bit of space, and I'm going to draw my lines. Again, if it's above the line, I add. If it's below, I multiply. I drop down my first term, and I start the zigzag pattern. So 2 times 1 is 2. I get a negative 6 when I add negative 8 plus 2. Then I multiply. Negative 2 times negative 6, I get a negative 12. I add 10 plus negative 12, I get a negative 2. I multiply. 2 times negative 2 is negative 4. I add. 2 plus negative 4 is a negative 2. I multiply. 2 times negative 2 is a negative 4. 4 plus negative 4 is 0. This is my remainder. So in this case, it is a factor. So yes, it is a factor. Now, some of you are probably wondering, why is this important? Why do we need to learn this? When we get to graphing, we are going to have to guess and check to find zeros in order to be able to graph it. It's very important to know the zeros, the x-intercepts, those are the same thing, in order to graph. And this is going to help us because we don't have the technology we need. I have 2 more examples just to kind of show you. So again, we take our binomial, we set it equal to 0. Remember, our binomials need to be in linear functions, meaning no x squareds, cubes to the fourth, and we don't want a number in front of the x. If it is, we have to take care of that. But in this case, we haven't had any like that, so we're okay. So I solve for x. Again, that goes into the half box. What this is telling me is that one of the zeros is -2. So my graph would actually go through that point. So that's kind of why we do that. Looking at it, I have an x squared, an x, and a constant. I'm good. I'm not missing anything. So I take the coefficients, and I now do synthetic division. Again, it's a quick process to do. So again, above we add, below we multiply. Drop down the first term. -2 times 4 is a -8. I add -2 plus -8. I get a -10. -2 times a -10 is a +20. I add 5 plus 20. I get 25. So this is not a factor because it is not equal to 0. The last example I have, if you notice this one, my binomial has something in front of the x. So when we have something like this, we have to divide everything by 3, even in the polynomial. You have to divide everything by 3 before you can do synthetic division, because we cannot have this number in front and do synthetic division. So when I do that, I am left with x minus 2 for my binomial. My polynomial, if I divide everything by 3, I get x to the 4th minus 2x cubed plus 2x squared plus x minus 10. And now I do the same thing that I've been doing. So I take x minus 2 and I set it equal to 0 because it's my binomial. I solve for x. I get x equals 2. That goes in the half box. Now I take the coefficients. So I have 1, -2, +2, +1, -10. If it's above, I add. If it's below, I multiply. I drop down my first term. 2 times 1 is 2. -2 plus 2 is 0. 2 times 0 is 0. 2 plus 0 is 2. 2 times 2 is 4. 1 plus 4 is 5. 2 times 5 is 10. -10 plus 10 is 0. So my remainder is 0, which means yes, this is a factor. So that is all there is to the factor theorem.